Hi dear students, in the last class we are discussing about the different preparation methods of alkanes. Okay dear students, now in the today's class we will discuss about that important chemical properties of alkanes. Okay, what are the important chemical properties of alkanes and reactivity of alkanes we will discuss. Once you observe that alkanes, the general formula is RH or CnH 2n plus 2. Okay, dear students. So generally, if you observe that alkanes, the molecular formulas, they have carbon and carbon single bond is present, and they doesn't have any other functional groups. Okay, they have only primary prefix is present, primary suffix is present, that is carbon and carbon single bond is present. They doesn't have any functional group. That's why alkanes are more stable. Alkanes are more stable and chemically inert are less reactive because of lack of a functional group. Under suitable conditions, the alkanes are most probably involving in free radical substitution reactions. Okay, dear students, free radical substitution reactions. So once you observe that organic types of organic reactions, one is substitution reaction, the second one is addition reaction, the third one is elimination reactions. Okay, again the substitution reactions are once you observe that the substitution reactions are three types are present. One is free radical substitution reaction. The second one is nucleophilic substitution reaction. Nucleophilic substitution reaction, and third one is electrophilic substitution reactions, dear students. Okay, so the free radical substitution reactions are most probably takes place in alkanes, by the formation of more stable free radicals as intermediates by the cleavage of carbon and hydrogen bonds or carbon and carbon bonds. Okay, dear students. So the alkanes are most probably involving in a free radical substitution reactions under suitable conditions. Okay. So nucleophilic substitution reactions, if you observe that most probably alkyl halides are involving in nucleophilic substitution reactions, and electrophilic substitution reactions, if you observe that most probably aromatic compounds means benzene and its derivatives, substituted benzene compounds are most probably involving in a electrophilic substitution reactions. Okay, dear students. So one kind of substitution reaction is free radical substitution reactions, in which free radicals are formed as intermediates. Okay, and that also most stable free radicals formed as intermediates. Once you observe that stability of free radicals, tertiary free radicals are more stable than secondary free radicals and then primary free radicals. Okay, dear students, one of the main important free radical substitution reactions of alkanes is halogenation reaction or halogenation of alkanes. Okay, so what is halogenation of alkanes? Halogenation of alkanes means alkanes reacts with halogens. Halogens means fluorine, chlorine, bromine and iodine in the presence of sunlight, or at a high temperature, and forms halogenated compounds. Halogen substituted compounds are the products. Okay, dear students, in this reaction, one or more hydrogen atoms are replaced by halogen atoms, that is called as substitution reaction. So these reactions are taking place by the formation of free radicals as intermediates. That's why this is called as free radical substitution reactions. Okay, and it is examples for free radical substitution reactions, and in which more stable free radicals are formed as intermediates. Okay, now in these reactions, halogens are involving this reaction. That reactivity order, fluorine is more reactive than chlorine as well, and then bromine and then iodine, dear students. Okay, that fluorination of alkanes even takes place in dark medium also. Sunlight is not required because of fluorine is highly reactive, and chlorination is required for sunlight, and bromination do you want to take place means sunlight and high temperature is required, and iodination reactions are very slow and reversible reactions. Iodination reactions are very slow and reversible reactions. Now the carbon and hydrogen bond, this it will be cleavage, then the hydrogen atoms are replaced by halogen atoms. Now which bond can be breaks very easily, which carbon and hydrogen bonds are more reactive in alkanes, that is tertiary carbon and hydrogen containing bond is more reactive than secondary CH bond and then a primary CH bond, dear students. Okay, just here observe that simple example for free radical halogenation of alkanes. Let's you have to take methane. That methane you have to do chlorination. That monochlorination if you are taking means 1 mole of chlorine and excess of methane you have to take in the presence of sunlight. Then we'll get CH3 bond Cl. That is 1 chloromethane is the product. That is called monochlorination by loss of HCl. Okay, is on further halogenation because these halogenation reactions are uncontrolled. These all alkanes containing all hydrogen atoms will be replaced. That is called excess of halogenation will take place. Is on further halogenation. Then again by loss of HCl. Up to how many times this chlorination will take place, dear students? That methane has 4 hydrogen atoms are present. That 4 hydrogen atoms are replaced by chlorine atoms. Means that reaction will take place up to 4 times. Then the final product is carbon tetrachloride will form. This is called. Then the product is CH2 Cl2. Means dichloromethane is on further halogenation in the presence of sunlight. Loss of HCl forms CHCl3, chloroform will forms. Again, this is on further halogenation in the presence of sunlight, loss of HCl to forms carbon tetrachloride is the product. Okay, so like halogenation, monohalogenation, dihalogenation, trihalogenation, and tetrahalogenation. Because that methane has 4 hydrogen atoms are present, that 4 hydrogen atoms are replaced. Okay, for example, ethane you have to take, dear students. CH3 bond CH3, ethane. Just you have to do monohalogenation in the presence of sunlight, loss of HCl, and only here ethane has only one kind of CH bonds only present, dear student. That is primary CH bond, and this is also primary CH bonds. That's why the product is CH3 bond CH2 bond Cl. Okay, is on further halogenation means chlorine in the presence of sunlight will get CH3 bond CH2, sorry, CHCl2 like that will form. Is on complete halogenation. Finally, we'll get CCl3 bond CCl3. Okay. CCl3 will form. Means 1, 1, 1, 2, 2, 2. Hexachloroethane is the product. Like that is halogenation reactions are uncontrolled reactions. Okay, this is about that halogenation reactions of alkanes, and iodination reaction is very slow. That's why iodination reactions are reversible reactions. To top the reversible reaction, the iodination reactions are generally carried out in the presence of oxidizing agents. Okay, let's see, dear students, iodination reactions. Iodination of alkanes. Iodination reactions of alkanes is very slow and reversible. Why it is reversible, dear students? Because of HI, the byproduct hydrogen iodide is strong reducing agent. Strong reducing agent. It reduces alkyl iodide into alkanes again. Alkyl iodide into alkanes, dear students. For example, methane you have to take. Methane is on iodination at high temperature. Then the product is methyl iodide and the byproduct is HI. This HI is reducing agent. Again, that HI reduces alkyl iodide into alkanes. Okay, to stop this reversibility reactions, therefore, iodination reactions takes place in presence of strong oxidizing agents. Strong oxidizing agents like HNO3 or HiO3, iodic acid or nitric acid. So these HNO3 or HiO3 are oxidizing agents, oxidizes Hi into immediately iodine. For example, HNO3 you have to take. This HNO3 is the oxidizing agent, okay, and it reacts, it oxidizes that Hi is the reducing agent into iodine immediately. Okay, dear students, 2 moles we need to take and 2 moles. Then to produce 2 moles of NO2 byproduct and 2 H2O. In the same way, the HNO3 place you have to take HiO3 is also. For example, HiO3 you have to take, dear students, iodic acid. It is also reduces Hi into iodine, Hi into iodine. Then we need to take 5 moles. Then produce 3 moles of iodine and 3 H2O will forms. Okay, so these are the oxidizing agents, oxidizes Hi, iodide, hydrogen iodide into iodine. That's why the reversible reaction does not take place. That's why CH4 is alkane, is on iodination. We need to carry out this reaction in the presence of oxidizing agents. Then the no reversible reaction, the product is CH3I. Again, the byproduct will be oxidized by HNO3 into iodine only. Then the product, final product will get methyl iodide is the major product, dear students. Okay, so the because of iodination reactions are very slow and reversible. That's why that reactions are carried out in the presence of oxidizing agents. It's very, very important point, dear students. Once you observe this mechanism, these reactions are free radical substitution reactions. The free radical substitution reactions mechanism is taking place in 3 steps. One is initiation, the second one is propagation, and third one is a termination. Third one is a termination, in which free radicals are formed as intermediates, dear students. Okay, let's see that mechanism. Okay, this mechanism is taking place in 3 steps. Free radical substitution reactions mechanism is taking place in 3 steps. The first one is initiation. Chain initiation or initiation reaction, initiation step. So these halogens, like I am taking here chlorine, dear students, the chlorine in the presence of sunlight and produce chlorine free radicals. This is called initiation step. And the second one is propagation, chain propagation. So you have to take chain initiation and chain propagation. Means it is a continuous process. This chain propagation, that alkanes, CH4 you have to take alkane, is reacts with chlorine free radical and produce the new free radical, that is CH3 free radical and HCl, the new free radical and neutral product will forms. Okay, again this CH3 free radical, the CH3 free radical reacts with chlorine to produce CH3 bond Cl neutral product and new free radical will forms. Like this step will be continuous, that is called as propagation step. And the termination reaction or chain end reaction, this is called termination reaction. Okay, termination step. Let's see, dear students, the termination means 2 free radicals combine to gives a neutral product. For example, the termination step, the methyl free radical and chlorine free radical combine to gives CH3Cl is the neutral product. Means the possibility of termination reactions I am writing here, dear students. And again chlorine free radical and chlorine free radical, if they are combined to give Cl2. Okay, and one more possibility is the methyl free radical and methyl free radical combined to gives ethane is also. This is the possible termination reactions. Among that, this is the major product, more quantity which will forms methyl chloride. Okay, the remaining are minor products will forms. Okay, this is the mechanism of free radical substitution reaction. Free radical substitution reactions of alkanes, that is called halogenation reaction, is taking place in 3 steps. One is initiation, the second one is propagation, third one is termination, dear students. Now from this free radical substitution reactions, means halogenation of alkanes, most probably for NEET and JEE examination, what kind of questions they are asking, that is called monohalogenation of alkanes. They will give one alkane is on monohalogenation, how many product will forms. That kind of questions are frequently and repeatedly asking in NEET and JEE examination. Okay, dear students, monohalogenation of alkanes. Let's see, dear students. Monohalogenation of alkanes. Find the number of products. For example, one carbon containing alkane, just you have to take, dear students. The first one is methane, you have to take. The methane is on monohalogenation. Just I am taking chlorine, and in the presence of sunlight to produce CH3Cl. Only one product will forms. Okay, one product. How many number of products are possible? That is one product. In the same way, just you have to take ethane, dear students. That ethane, it has only one type of CH bonds are present, that is primary, and this is also primary, and AA type of carbons. Both carbons are similar type only. Is on chlorination, will get only one kind of product. One kind of monohalogenated product will get, that is one chloroethane. Okay, this is also only one product will forms. Okay, one isomer or one product is possible. Now let's see, dear students, propane you have to take. Propane, it has 3 carbon atoms containing alkane. If you observe that propane has 2 primary carbons, this end carbon CH3 carbons are similar type, at that carbon hydrogen atoms are replaced, then we'll get only one kind of product. And middle CH2 carbon is different type, it is a secondary carbon, and we'll get 2 products, that is 1 chloropropane and 2 chloropropane. Okay, this CH bond, this carbon and hydrogen bond is breaking, then primary free radicals are the product, or the intermediate will form, and here secondary free radicals are formed as intermediate. Secondary free radical. Okay, secondary free radicals are more stable when compared to primary. That's why this product is major product. Sometimes which is the major product also they will ask, and number of monohalogenated products are 2. 2 products are possible. Okay, 2 products, among that 2 chloropropane is the major product. The same way, 4 carbon atoms containing alkanes, if you are observed that there are 2 chain isomers are present, one is N-butane, the second one is isobutane. N-butane. Okay, if you are observed that N-butane on monohalogenation, here I am using chlorine, dear students. Now if you are observed that it contains this end CH3 carbons are similar type, and middle CH2 secondary carbons also similar type. If you are replaced at any CH2 carbon, will get only one kind of product. If you replace that any end CH3 carbons, hydrogen atoms you replaced, will get only one product. That is one chlorobutane, and the second one is 2 chlorobutane is the product. 2 chlorobutane is the product. Okay, dear students, here like monohalogenated products, we are getting only 2 products are possible. Okay, this is CH3 and Cl, and here H will be present, and here 1, 2 ethyl carbon is present. So 2 products are possible. 2 products. And once you observe that this carbon is asymmetric carbon or chiral carbon will be present, dear students. Here 4 different groups are present. Chlorine, hydrogen and ethyl. C2H5 group is present, and here CH3 is present. Okay, and this is the chiral carbon. Chiral carbon are asymmetric carbon. It produces two isomers. So one asymmetric carbon is present, means two isomers are present, one D and L. So total here two isomers and it is one. Then total three isomers are possible, dear students. So the number of isomers are 3 and number of monohalogenated products are 2 for N-butane. Let's see, dear students. The next one is isobutane. This is isobutane, dear students. This isobutane is on monohalogenation. We'll get how many types of products? This A is CH3R primary only. A and A type, and this is a B type of product. Okay, then we'll get two products only possible. Two products, and no one product doesn't have any chiral carbon. Two products. What are those two products, dear students? The two products are CH3, CH bond CH3 bond CH2 bond Cl, and another one is CH3 bond Cl bond CH3, means tertiary carbon containing hydrogen will be replaced, and it is the major product. 2-chloro-2-methyl propane is the major product. Okay, dear students, and they doesn't have any chiral carbon or asymmetric carbon, means number of isomers are 2 only and number of products also 2 only. Okay, this is about for isobutane and N-butane. Okay, let's go for pentane. 5 carbon atoms containing alkanes is on monohalogenation. How many kinds of products are possible? Let's see, dear students. For example, N-pentane, CH3 bond CH2 bond CH2 bond CH3. Now total 5 carbon atoms are present, dear students. Now once you observe that here the position, this end carbons are similar, only AA type, and this CH2, this CH2 are same kind, B and B, and the middle CH2 is a third type. If that at middle carbon, at middle CH carbon hydrogen atoms are replaced, then we'll get 3 halo, means 3 halogenated alkane is the product. That is different. So is on monochlorination. In the presence of sunlight, we'll get 3 products. Okay, 3 products. What are the 3 products? Let's see, dear students. The one is one chloropentane, 1, 2, 3, 4, 5, and the second one is 2 chloropentane. And this 2 chloropentane, this chlorine attached carbon is a chiral carbon. Chiral carbon, because this right side at this carbon, the 4 different groups are present. One is chlorine, hydrogen, and CH3, and the remaining C3H7 is present. Propyl group is present, and methyl group, chlorine and hydrogen. So it has 2 isomers are present. 2 isomers. So number of isomers are 2 are present for this, and the third one is 3 chloro. Like just you have to write pentane, and this is the 3 chloropentane is the product, and it doesn't have any asymmetric carbon or chiral carbon, because this right side ethyl group is present and here also ethyl group is present, symmetrical. At this carbon, hydrogen, and right side groups and left side carbons are similar. It is a symmetrical group, means the third point is from right side 2 carbons and left side 2 carbons are present. That's why is not a chiral carbon, is only just a 3 chloropentane is the product. But 2 chloropentane has 2 isomers are present, because it is optically active compound. The 2 isomers, 1 asymmetric carbon is present, means the number of optical isomers are 2 power n, where n is equals to 1, means D and L, 2 isomers are present. Total isomers are 4 isomers are present, dear students. 4. And the number of monohalogenated products 3. The same way, let's see one more compound, that N-pentane over. The next one is isopentane. Isopentane is on monohalogenation. We'll get how many number of monohalogenated products will form. Let's see, dear students. This CH3 and this CH3 isopropyl group. That iso group, 2 CH3 groups are similar. Only will get only one kind of product, and the tertiary carbon is another kind. And this C and D, total 1, 2, 3, 4 products are possible. 4 products. Out of these 4 products, 2 products are optically active, and they having one asymmetric carbon is present. They produce 2 plus 2, 4 isomers are possible. 4 plus 2 total, and 6 isomers are present, and 6 isomeric products. 6 isomers are possible. Okay, dear students, let's see what are the 6 isomers. I will write that from first one onwards. At that any A carbon, A marked carbon, you have to remove hydrogen, we'll get one product, that is Cl bond CH2 bond CH bond CH3 bond CH2 bond CH3. Okay, once you observe that this structure, this carbon, this tertiary carbon, if you observe that the different groups, one is CH2Cl group, another one is ethyl group, and methyl group is present. And this is the chiral carbon. Chiral carbon, so it has 2 isomers are possible. Okay, dear students, and the second product is at D carbon, you have to replace the hydrogen atom, we'll get the product is CH3 bond C bond Cl and CH3 and CH2 bond CH3. Here no chiral carbon. And at C carbon, you have to replace the hydrogen atom, we'll get asymmetric carbon, and that's why the product has 2 isomers are present. The chlorine and the CH3. Once you observe that groups, this is the chiral carbon, dear students. Chiral carbon or asymmetric carbon, it has 2 isomers. Okay, because the right side CH3 group is present, at that carbon one chlorine and hydrogen groups are present, and the left side isopropyl group is present. 4 different groups are present. That's why 2 isomers are possible. And another product is at D carbon, just you have to replace, then the product is CH3 bond CH bond CH3 bond CH2 bond CH2Cl. Okay, and it doesn't have any asymmetric carbon or chiral carbon. So there are total 4 monohalogenated products are present. Among the 4 monohalogenated products, 2 are optically active because of they having one asymmetric carbon. So due to the presence of one asymmetric carbon, it exists in 2 isomeric structures, 2 isomeric forms. Those are D and L forms, like 2 compounds. Okay, then the total isomers, possible isomers, formed isomers are 6 are present. Among that 2 are optically active isomers. Okay, 2 products are optically active, they are producing 2 plus 2, 4 isomers are producing. Okay, and another important monohalogenated product is neopentane. Neopentane is on monohalogenation, will get how many products? Okay, dear students, the product is only one product is possible, because this all carbons, all CH3 carbons are similar type only. A and A and A, and this is the quaternary carbon. At this quaternary carbon, there is no hydrogen atom. That's why it doesn't undergo any free radical substitution reaction. Now the product is only one product. One product, dear students. Now Based on this monohalogenation, what kind of questions they're asking? Let's see, dear students. Its gram molecular weight is 72. Okay, 72 AMU or 72 grams. If alkane gram molecular weight is 72 AMU or 72 grams, is on monohalogenation. Is on monohalogenation. Is on monohalogenation forms one product. Is on monohalogenation forms one product. What is the alkane? What is the alkane? Okay, what is the alkane? They will ask. In options, they will give N-pentane, isopentane, and third one is neopentane. The fourth one is hexane or N-hexane. Like they will give. So the answer is neopentane. Neopentane, pentane or isopentane, all are having same molecular formula, but those all are chain isomers, and their gram molecular weight is 72 only. But N-pentane is on monohalogenation, producing three products. Isopentane producing 4 products, and neopentane is producing only 1 product. So here one monohalogenated product containing alkane we need to identify. So the answer is neopentane. This kind of questions are repeatedly asking in NEET and JEE examination also. And number of monohalogenated products, that number they will ask in integrated questions also, dear students. Okay, this is about halogenation of alkanes. Okay, now this alkanes means hydrocarbons, they having allylic position as well as benzylic position is present. Then that allylic free radicals as well as benzylic free radicals are more stable when compared to tertiary free radicals. Then that halogenation is known as allylic and benzylic halogenation reaction. So the good allylic and benzylic brominating agent is NBS, N-bromosuccinamide. It is very, very good allylic and benzylic brominating agent. Okay, now we'll discuss about that allylic and benzylic free radical substitution reaction or allylic and benzylic halogenation reactions. Okay, dear students, let's see allylic and benzylic halogenation reaction. Okay, what is allylic and benzylic positions? Let's see, dear students. For example, benzene ring is attached to sp3 carbon. That carbon is known as benzylic carbon. Like ethyl benzene is present, dear students. This position is known as benzylic carbon. Next, allylic position is sp3 carbon is attached to sp2 carbon. sp3 carbon is attached to sp2 carbon is known as benzylic allylic position. This is known as allylic carbon or allylic position, and this is primary carbon. Okay, and it is also primary carbon, dear students. Now we want to do halogenation. Just you have to do chlorine in the presence of sunlight at high temperature or around 500 degrees Celsius temperature. The both case where that halogenation will take place. So the halogenation will be takes place at benzylic position as well as allylic position. Now we know that allyl benzyl free radical more stable than allyl free radicals. Allyl free radical, and then tertiary, and then secondary, and then primary. Now the halogenation will be takes place chlorination at benzylic position, and here also chlorine will be substituted at allylic and benzylic position. These are called as allylic and benzylic halogenation reactions. And another important, you want to do bromination, that allylic and benzylic bromination, then we need to use NBS, N-bromosuccinamide. N-bromosuccinamide is a good allylic and benzylic brominating agent, dear students. So in this chlorine place, if you are used okay, if you are used NBS, N-bromosuccinamide is a good allylic and benzylic brominating agent, and the bromination will be takes place at allylic and benzylic positions only. Okay, this is about allylic and benzylic halogenation reactions. For example, now one hydrocarbon is present like this. It is on reaction with chlorine in the presence of sunlight. What is the major product? The major product we need to identify. Okay, what is the major product, dear students? The major product, if you want to identify, means let's see that it is a free radical substitution reaction and it is a primary carbon. Okay, and this is also primary carbon, and it is a tertiary carbon, and it is benzylic carbon. Benzylic carbon. So in which free radicals are formed as intermediates. Among that, benzylic free radical is more stable than tertiary and then primary. So that's why the major product will be at benzylic position, chlorination will take place when compared with the tertiary carbon is the major product. Okay, dear students. So this kind of questions are asking in NEET and JEE examination. Okay. Let's see next important chemical property of alkanes is that is nitration of alkanes. Nitration reaction. Okay. So the nitration reaction. Let's see, dear students. Alkanes reacts with vapor phase nitric acid, HNO3. The vapor phase nitric acid, HNO3, and to produce nitroalkanes. Produce nitroalkanes. Okay, it is also free radical substitution reaction. It is a free radical substitution reaction. So once you have updated that mechanism, this HNO3 will be undergoes homolytic cleavage to produce OH free radical and NO2 free radical, and carbon and hydrogen bond will be breaks to produce alkyl free radical and hydrogen free radical. And these two will combine to forms water and RNO2, nitroalkanes will be formed. So in this nitration of alkanes, carbon hydrogen bonds will break, and carbon bond also will be cleavage. Cleavage takes place. Okay, carbon and hydrogen and carbon bond cleavage also will take place, and carbon hydrogen bond cleavage order, reactivity order. Reactivity order is tertiary. Carbon hydrogen will be cleavage very fast and produce more stable free radicals, and then secondary, and then primary. In all free radical substitution reaction, the cleavage of carbon and hydrogen is the same order only. Have to remember, dear students. For example, CH4, methane is present, is on reaction with vapor phase HNO3, nitric acid to produce nitromethane. Okay, nitromethane, HNO2, nitromethane plus water. For example, ethane you have to take, dear students. That ethane, here carbon and hydrogen bonds are present, and carbon and carbon bonds also be present. So if it is undergoes, if it is reacts, the cleavage is takes place CH and CC bond cleavage. Both two types will be possible. Among that, CH bond cleavage is the major product. So the major product is CH3 CH2 bond NO2, nitroethane. Along that, the byproduct CH3 NO2, nitromethane is also possible. Okay, dear students, because of nitration reactions, in which in alkanes carbon and hydrogen bond as well as carbon and carbon bond also cleavage takes place and produce mixture of nitro alkanes are the products. Mixture of nitro alkanes are the products. Okay, dear students. Now, actually here that mixture of nitro alkanes are producing. That's why you want to form nitro alkanes. The suitable method for the formation of nitro alkanes. The suitable method for the preparation of nitro alkanes means you have to take directly alkyl halides reacts with silver nitrate, AgNO2. Silver nitrate, it undergoes nucleophilic substitution reaction. It is a nucleophilic substitution reaction. Okay, then producing nitroalkanes as the major product. Okay, and AgX. This is the alternate method for the preparation of nitroalkanes when compared with the alkanes. Okay, nitroalkanes do you want to prepare means you have to take alkyl halides reacts with silver nitrate and produce nitroalkanes as the major products. Okay, and this reaction is nucleophilic substitution reaction. When alkanes reacts with vapor phase nitric acid, produce nitroalkanes. That reactions are belongs to free radical substitution reactions. Okay, dear students, and let's go for next important chemical properties of alkanes is sulfonation reactions. Sulfonation reactions of alkanes. So here the product is alkyl sulfonic acids. So the product is alkyl sulfonic acid. Product is alkyl sulfonic acid or SO3H. Alkyl sulfonic acid is the product. Okay, in this alkanes reacts with sulfuric acid or oleum or fuming sulfuric acid. Fuming sulfuric acid is also called as oleum, H2S2O7 or sulfuric acid to produce alkyl sulfonic acid. Alkyl sulfonic acid is the product. Okay, dear students, for example, alkanes RH you have to take and treated with sulfuric acid. Okay, it is a free radical substitution reaction, dear students. In which the bond RH bond, carbon and hydrogen bond will cleavage. In sulfuric acid, the OH bond will cleavage, and this free radical both combine to produce RSO3H. Alkyl sulfonic acid is the major product, and byproduct water will forms. Okay, dear students. Now, for example, CH4 treated with H2SO4 to produce methyl sulfonic acid. CH3 bond SO3H is the product. Okay, now you want to produce alkyl sulfonic acid. The alternative method for the alkyl sulfonic acid is alkyl halides you have to treat with sodium sulfide and will get alkyl sulfonic acid. and that reaction is known as Streaker's reaction. That reaction is known as a Streaker's reaction. For example, ethane you have to take, dear students, that ethane reacts with H2SO4 to forms ethyl sulfonic acid, CH3 bond CH2 bond SO3H. And propane, if you are taking that, the major product is isopropyl sulfonic acid. Isopropyl sulfonic acid is the major product, and compared to propyl sulfonic acid is the minor product. Okay, alkyl sulfonic acids are the major products. Now, alternative method. The alternative method for the synthesis of alkyl sulfonic acids is known as Streaker's reaction. Streaker's reaction. What is Streaker's reaction? Let's see, dear students. The Streaker's reaction is nothing but you have to take alkyl halides. It is nucleophilic substitution reaction only. Reacts with sodium sulfide. Na2SO3 forms loss of NaX to produce R S double bond O ONA. Is on hydrolysis in acidic medium to produce RSO3H. Okay, so once you observe that the reaction mechanism S double bond O ONA and ONA. Na plus and O minus. Now here this sodium halide will loss and this O minus will be goes to sulfur and forms S double bond O, and the nucleophilic group is sulfur. That S minus will be attached to the R here, positive and negative. Then forms S double bond O, S double bond O, ONA will forms O minus and Na plus. Okay, is on hydrolysis, will getting alkyl sulfonic acid. This reaction is known as a Streaker's reaction. Okay, it is alternative method for the synthesis of alkyl sulfonic acid when compared with alkanes. Okay, dear students, let's see the next important chemical properties of alkanes is. The next important chemical properties of alkanes is combustion of alkanes. Combustion reactions is nothing but oxidation of alkanes. That is complete oxidation, controlled oxidation, and partial oxidation. Like two types of oxidations are present, dear students. Complete oxidation of alkanes you did means we will get carbon dioxide and water, and that reactions are highly exothermic and releases more heat. That is also known as combustion of alkanes. If controlled, partial combustion if takes place means the forms carbon or carbon monoxide and water will they forms. Okay, dear students. And controlled oxidation if you did, then we'll get different types of products. This depends on the nature of a catalyst. Depends on the nature of a catalyst. Let's see, dear students, oxidation of alkanes. Okay, next important chemical properties. Oxidation reactions of alkanes. Oxidation reactions of alkanes. Okay, let's see, the first one is complete oxidation. Complete oxidation or uncontrolled oxidation. It is also called uncontrolled oxidation or combustion reaction. Okay, dear students, alkanes general formula we know very well, dear students. Alkanes CnH2n plus 2 means alkane reacts with 3n plus 1 by 2 moles of O2 oxygen. then produce n moles of carbon dioxide and n plus 1 moles of water and releases heat. It is exothermic reactions. It is exothermic reaction. Okay, dear students, if n is equals to 1, if you are taking, then CH4, then you will get n is equals to 3n. 3 plus 1 means 4 by 2 is equals to 2 moles of what is required. Produce 1 CO2 plus 2 H2O and releases heat. It releases high heat. If n is equals to 2, you have to produce, that's why it is general equation. CnH2n plus 2 is on complete oxidation, requires how many moles of oxygen? 3n plus 1 by 2 moles of oxygen is required, and produce n moles of CO2 and n plus 1 moles of O2. Okay, forms CH3 bond CH3. And n is equals to 2, if you are substituted 6 plus 1, 7 by 2. 7 by 2 moles of O2 means 3.5 moles of O2 is required. Produce 2 moles of CO2 and this n is equals to 2 means 2 plus 1, 3 moles of H2O and heat. It releases heat. Okay, this is about complete oxidation. Now incomplete oxidation, if you are taking, second one is incomplete combustion or oxidation forms, incomplete combustion or oxidation forms carbon monoxide and carbon monoxide and carbon, it will forms. Okay, dear students, for example, CH4, methane, if you are taking, that methane is on incomplete combustion to produce carbon monoxide, CO, and water, CO and water, 2H2O. Okay, total 4 oxygen atoms are present, and here here 1 is present, and here 2 are present, 3. So if you are taking 2 moles, then you will get 2 moles of CO, and here 2. Total 4 is okay. Then 8 hydrogen atoms are present. Sorry, dear students. O2 and forms CO, carbon monoxide and H2O. If you are taking for complete combustion, it produces carbon monoxide. Then two H2O. You are taking 2 moles of O2 and forms 2 CO and 8 means 4 H2O. Here 4 plus 2 6 means 3 moles of O2 we have to take, and heat it will produce. So incomplete combustion and produce carbon monoxide, or sometimes carbon also it will forms. If it is forms carbon, this is also called as carbon black. Okay, and forms 2H2O and releases heat, and it is also exothermic only. This carbon black has importance is present. It is used in it is used as printers, ink, and black pigment. Black pigment means for making of black colors, and printers ink, and this carbon black is also used in filters for the filtration of impurities. In such cases, this carbon black are using. Okay, dear students, this is about incomplete combustion. Now the third one is controlled oxidation of alkanes. Let's see, dear students. The next one is controlled oxidation. Controlled oxidation. Oxidation of alkanes. So this controlled oxidation of alkanes producing different types of products. This depends on the nature of the catalyst. If catalyst is changed, automatically the product will be changes. And these controlled oxidation reactions are very, very important. Directly they are asking the questions in NEET and JEE examination. So we must have to remember that controlled oxidation reactions with catalyst. What is the catalyst we are using? What is the alkane we are using? And what is the product? And everything we have to remember, dear students. The first one is controlled oxidation, means just you have to take methane, dear students. Methane is on controlled oxidation in the presence of the catalyst is copper. Copper catalyst at 523 kelvins temperature and 100 atmospheric pressure and forms methyl alcohol, CH3OH. Methyl alcohol is the product. Just you have to balance this 2 moles and 1 mole of O2 forming 2 moles of methyl alcohol. So here the catalyst is copper. Methane is on controlled oxidation in the presence of copper catalyst. The product only you have to remember, that is methyl alcohol. Okay, and let's see that second controlled oxidation reaction, dear students. You have to take methane. That methane you have to do controlled oxidation in the presence of catalyst is molybdenum oxide, MO2O3, molybdenum oxide, and the product is formaldehyde. Formaldehyde is the product. Okay, the product is a formaldehyde. So here the catalyst is a molybdenum oxide. And the third one is the third controlled oxidation is alkanes. You have to take the alkanes is on higher alkanes. RCH3 means higher alkanes is on controlled oxidation in the presence of manganese acetate, CH3COO twice Mn. So the catalyst is manganese acetate, dear students. Then this higher alkanes, the higher alkane, the CH3 group is converted into acids, RCOOH, carboxylic acids, and water. Okay, so the carboxylic acids are the product. So just you have to balance this, dear students. So 2 moles of higher alkanes reacts with 3 moles of oxygen and produce 2 moles of RCOH and 2H2O. Okay, so if R is equals to CH3 you are taking, then ethane. Ethane is on controlled oxidation in the presence of manganese acetate, produce acetic acid or ethanoic acid is the product. Okay, ethanoic acid is the product. Okay, is very, very important, dear students. Next, the fourth important controlled oxidation reaction is you have to take tertiary hydrogen containing alkanes, CH3, CH, bond CH3, bond CH3. Okay, this is the tertiary hydrogen. Tertiary CH hydrogens is on controlled oxidation in the presence of alkaline KMnO4, potassium permanganate. Alkaline potassium permanganate is also known as Bayer's reagent. It will be converted into tertiary alcohols. The tertiary CH group, oxidized into tertiary alcohol in presence of KMnO4. Okay, Bayer's reagent. So this is known as tertiary butyl alcohol. So isobutane is on oxidation in the presence of alkaline KMnO4 forms tertiary butyl alcohol. Okay, dear students, one more controlled oxidation reaction is methane. You have to take that methane is on controlled oxidation, with water vapors. Okay, and methane is passed through water vapors in the presence of nickel catalyst at 350 degrees centigrade and forms carbon monoxide and H2. This is known as water gas. This water gas also has another names are present. Then it is also called as syngas or synthesis gas. Synthesis gas. Okay. So CO plus H2 combination is called as water gas. CO plus N2 is called producer gas. That also you have to remember, dear students. One more controlled oxidation of alkanes is, that is alkanes. You have to take higher alkanes treated with ammonia, reacts with ammonia and oxygen and produce alkyl cyanides. For example, RCH3 treated with ammonia and on oxidation, okay, in presence of catalyst at 500 to 600 degrees centigrade temperature and forms RCN. Alkyl cyanides are nitriles. Alkyl cyanides is also called as nitriles. So you have to balance this 2 moles of alkanes and 2 moles of ammonia and 3 moles of oxygen. Means alkanes reacts with ammonia is on oxidation at 500 to 600 degrees Celsius temperature, is on heating, produce alkyl cyanides. Alkyl cyanides are the products. So these are the important controlled oxidation reactions of alkanes, dear students. All are very, very important. Next important chemical properties of alkanes is isomerization, aromatization, and pyrolysis reactions of alkanes. Okay, let's see, dear students. The next one is isomerization of alkanes. Isomerization. So in this isomerization reaction, the catalyst is, this point is very, very important. Catalyst for this isomerization is AlCl3, aluminum trichloride, dear students. Higher alkanes, N-alkanes converted into branched alkanes. So N-alkanes in the presence of AlCl3 converted into branched alkanes. Okay, dear students, for example, N-butane you have to take. N-butane is on isomerization in the presence of AlCl3, forms isobutane. The same way you have to take N-pentane. 1, 2, 3, 4, 5. N-pentane is on isomerization in the presence of AlCl3 to produce isopentane and neopentane. Isopentane and neopentane. Okay, these are the products. So higher alkanes, N-alkanes are converted into branched alkanes in the presence of AlCl3. So the AlCl3 is called isomerization catalyst. Okay, dear students, the next important chemical property is aromatization. Aromatization reactions or aromatization of alkanes. So in this aromatization alkanes, N-alkanes, the carbon atoms, 6 or more than 6 atoms containing N-alkanes. Higher N-alkanes, the carbon atoms, number of carbon atoms 6 or more than 6. Okay, this N-alkanes is on aromatization to produce aromatic compounds. Aromatic compound means benzene, are substituted benzenes. Benzenes are the product. Substituted benzene is the product. So here that aromatization catalyst is main important catalysts are vanadium oxide V2O5 or vanadium oxide or molybdenum oxide or chromium oxide. These are the aromatization agents, dear students, very important. Then loss of H2, hydrogen will loss and converted into benzene or substituted benzenes. For example, N-hexane you have to take 1, 2, 3, 4, 5, 6 N-hexane is on aromatization in the presence of either vanadium pentoxide or molybdenum oxide or chromium trioxide. These are the catalysts and converted into benzene. Benzene molecular formula is C6H6. Okay, benzene is the product. Its molecular formula is C6H14, means alkane. 6 carbons, then 6 carbon atoms containing aromatic compound, that is benzene will get. Means 6 hydrogens out of 14, 6 are present. The remaining will goes to loss of H2, dehydrogenation. This is removing of hydrogen atoms, and open chain compounds are converted into cyclic compound. So here we'll get 4H2. 4H2 will comes outside. In the same way, N-heptane you have to take. N-heptane means C7H16. The same, then we'll get methyl benzene. Methyl benzene is the product. This is also called as toluene. Plus hydrogen atoms, how many will be present here, students? Here C6, C7H8. So the remaining out of 16, 8 are with aromatic compound. The remaining will comes to H2. Okay, 8 is over, means 4H2 will be formed. 4H2. So the toluene will be formed. N-heptane, toluene. N-octane if you are used means ethyl benzene. N-octane. N-octane if you are used means we will get ethyl benzene or 1,2 dimethyl benzene, that may be ortho or meta or para products, like a mixture of benzene substituted compounds will form. Alkyl benzenes are the products will form. Okay, ethyl benzene, among that ethyl benzene is the major product. Okay, dear student, this is about aromatization reactions of alkanes. Next one is pyrolysis reactions of alkanes. What is the meaning of pyrolysis? Pyrolysis of alkanes. Pyrolysis reaction means cracking of alkanes in the absence of air. So alkanes, the pyrolysis reaction means the reactions takes place in absence of air. Alkanes are heated. Alkanes are heated in the absence of air. Absence of air to forms here higher alkanes. Higher alkanes are heated in the absence of air to forms lower alkanes or lower hydrocarbons. Lower hydrocarbons by cleavage of CH and CC bond. By the cleavage of CH and CC bond. For example, CH3 bond CH3. Ethane is on heating, means pyrolysis will be takes place at 450 degrees Celsius. You are heating, then the CH bond will break to produce CH2 double bond CH2 plus H2. Ethene is the product. Okay, and for example, this pyrolysis reaction is mainly, this pyrolysis principle is mainly useful in that refining of petrol or petroleum refining process. It will be useful. For example, dodecane means 12 carbon atoms containing alkane, C12H24. It is called dodecane. Okay, it is called dodecane. Dodecane means 12 carbon atoms containing alkane. This dodecane is also called as fuel, that is nothing but kerosene. We are using this well-known compound that is called kerosene. Its IUPAC name is dodecane. Is on pyrolysis at 973 kelvins temperature. We'll get in the presence of palladium or platinum catalyst. We are getting C7H16. N-heptane or heptane is the product. Heptane and the remaining pentene, C5H10. Pentene, the mixture of products will form. Means higher carbon atoms containing alkanes are converted into lower carbon atoms containing hydrocarbons. It may be alkanes or alkenes are the products. Okay, these reactions are known as a pyrolysis reaction. This pyrolysis reaction is mainly useful in petroleum industry, refining of petroleum, because kerosene and petroleum products we are refining means the absence of air only, they are using, they are heating at high temperature, then we are getting lower carbon atoms containing hydrocarbons, alkanes. Those are used as a fuels. Those we are using as a fuels. That's why this pyrolysis principle is mainly we are using in refining of petrol and petroleum products. Refining process mainly we are using. So these are the main important chemical properties of alkanes. So alkanes we are mainly using in the main importance of alkanes is nothing but alkanes are mainly we are using as a fuels. Mainly we are using as a fuels. So for example, petrol, diesel, kerosene, these all are hydrocarbons only. So that's why alkanes are mainly useful as a fuels, and these are the main important chemical properties of alkanes. So alkanes main important chemical properties are free radical substitution reaction, that is halogenation, nitration, sulfonation. And another important thing is that is oxidation. One is complete oxidation, that is called combustion, and incomplete combustion, and controlled oxidation, isomerization, aromatization, and pyrolysis. Okay, dear students, thank you for all. So please everyone subscribe my channel, and you will get more updates related NEET and JEE and IPE examination, 11th and 12th chemistry. Thank you for all.